G'day and welcome to another Visions of Cars tutorial. This tutorial is part 2 about local vibe coding and a follow-up to my first vibe coding tutorial. Okay, first of all we will do a quick demo of how to install Llama CPP and Hermes in Visions of Chaos. You can use the search, look for Llama CPP. When you first start Llama CPP, if it has not been installed yet, the install option will be visible. Click that to install. Most of this is hands-free, so just wait for all the downloads and installs to complete. Once you get to this stage here, the Hermes agent UI will be installed. When it first opens, click Install Hermes and wait for it to finish. And then once it completes, just close it. So we'll do that now. So just press any key and you get this graphical install. Just click Install Hermes and wait for that to finish. Okay, so once that is done, don't click Launch Hermes. Just close this window and then you will see that the install is finished and press any key to continue. Once that install is finished, the required models will be downloaded for you. So just click OK. And then wait for those downloads to finish. Okay, so once those downloads finish, just press any key to continue. And you'll be prompted to just restart Visions of Chaos. Say yes. And you'll now notice on the Llama settings dialog, the model drop-down has got the models downloaded. There are the Gemma 4 models, which are from Google. There is a GPT OSS model, which is from OpenAI, and there are the Quen models from Alibaba. After I did a lot of tests with the models, the current best model for local vibe coding is definitely the Quen 3.6 27B model, and so I recommend that. So highlight that and check Start Hermes CLI with Llama CPP. And so that launches Hermes once it has launched the backend Llama CPP. So check that and click Start. As you'll notice that every time that Hermes starts, it does a quick check. Because it's constantly being updated, this makes sure you always have the latest version. Okay, so once those updates are finished, you will see the Hermes agent appear. So the main tip for this tutorial is this new template that I use to generate the vibe coding results. The most important part of this new template is the goal command. Goal tells Hermes to work a lot harder on solving the problem. So if you have a prompt that the AI has been having trouble with, adding goal makes it work harder. What this does is it repeatedly works on the problem up to 20 times by default to solve what you want done. And so let's just have a look at the rest of this prompt that I'm going to use. Write me a JavaScript app in a single HTML file. I choose this because a JavaScript app is self-contained in a single HTML file and I can quickly demonstrate that when it's written. The next section should be your description of what you want to be coded. You can be brief or very detailed here depending on if you really want to tell it exactly what it has to do or if you want a more general term to see if it can find some different versions for you. Now, as an example here, we will try this prompt. It should be a simulation of different species fighting for survival in a world. Balance the species properties so they can all survive long-term together. Okay, so that's the prompt for the sort of app we want. Let's have a look at the rest of these. Search the web and research extra information and example code to help. And what this line does is it instructs the AI to use its web searching capabilities. If you have found an AI can hallucinate and follow its own ideas sometimes, which are completely wrong, including this line asking it to search the web, you can then go out and hopefully find some example code and information that is correct to help. Okay, and the next line, write a fully detailed information plan.md before starting. And what this gets the AI to do is it actually implements its own plan first before actually starting to code. And you will see that shortly when I run this prompt. And the next line, follow the plan exactly when implementing the actual code and test and verify each part of the plan as you go. You can use the vision tool to visually verify outputs. The vision tool is part of Hermes that can launch an app and visually look at how it looks. And so if there's something that doesn't look right, it can see that and try and fix it itself. And finally, add debug stats to catch any errors and show the errors in a text window so they can be copy pasted into here if need be. So if your app has got proper error catching and it shows those errors if something goes wrong or the app crashes, you can then copy paste those back into Hermes and say, hey, fix this. Rather than just saying, I ran the app and it hung, you can say, okay, I ran the app and it gave these error messages, which will help it find the actual problems and fix them. And so that's the current template that I'm using for my vibe coding. So let's copy that into Hermes and let that run and see what it gives us. So you just copy paste, press enter, and off it goes. Using the /goal, it will be slower as it goes through and does all these separate little steps and launches different agents and tools and skills to try and help make its final result the best possible. Okay, so it has now written the plan and it's now going to start actually coding it. And so we can see here it's decided to make a ecosystem with plants, herbivores, lions, spiders, wolves, bears, and fungus as our different species. Another tip here is to have Task Manager open. And if you click on your GPU, if you're across the room just glancing over at this, you can see once it finishes because this will then drop down to 0. But back here now, so it has now created the file, written the HTML, and so it's going to test it in the browser. And so it launches a hidden browser window to check if there's any errors. And it looks like it's running fine, it didn't find any. And so it now takes a visual screenshot and it checks that too. And then it finds this, the simulation ran, but all non-plant species went extinct. Plants overpopulated and filled the grid. This is a classic balance problem. Let me fix the simulation with better balancing, which is why I specifically asked it balance the species properties so they can all survive long-term together. And so it's found some recommendations itself. Density-dependent reproduction. Species slow down when too crowded. Herbivores need much higher reproduction to control plants. Plants need slower growth, better energy systems, population pressure mechanics. While it's still working on the problem and writing a new version, let's have a look at the plan that it created to start with. So my Visions of Chaos is under V, VOC, and then Hermes will output under Machine Learning, Llama CPP, and Hermes. So we can find the plan there. And if we just have a look, and so you'll see it has written a fairly substantial plan itself for how it thinks it's going to work. It thinks about the UI, the rendering, the engine itself, statistics, population, and a plan on which order to actually code all this stuff, which then helps it code this system up better because it's got a more of a concrete plan to follow. Okay, and here we have it again. The balance is still off. Herbivores overpopulate this time. Eat all the plants, then predators starve. I need to rebalance. Increase herbivore metabolism, reduce their reproduction efficiency, and give predators better survival. Let me fix this. And so this shows how using Hermes and the /goal saves you those extra steps of waiting for the AI to code the next version, you having to copy paste that out, run it, see if it works. If not, telling Hermes the plants all die too quickly and then the herbivores die and then the predators die, and then asking it to keep going. Whereas here is a single prompt and it just handles most of it itself. It is still not perfect, and you will get times you do have to do extra prompts depending on how complicated your idea is. But using this goal method seems to get most apps within 95% of your final version you want. Okay, so it's still having balancing problems here. Better, plants are balanced, but all four predators are still declining. They need lower metabolism or higher energy returns. Okay, everything went extinct that time after 100 step. I need to significantly rebalance. Okay, well, do your best. So at this point, I would normally launch Task Manager, and so I can see if it's still working across the room, and I'd go and do other tasks and occasionally just glance over and see if this is still flat out working. So let's just wait until it is really finished and it thinks it's given us a good result. Okay, so after 38 minutes, that one has completed. If you scroll back up, you can see all of the various edits and thoughts, etc., that Hermes had. So when we left, let's see, it was around probably version 3 or 4 it was working on. So I continued to check, and various things went wrong. Getting that balance right was very tricky, it seems. But it kept on trying little tweaks along the way, debugging itself, patching. Excellent progress, but not yet. And it had a problem with the fungus for a while, and then the fungus was fixed, but it was thriving too much. So more balancing. And then it reaches this stage here. I've been going back and forth too much on tuning. Let me rewrite with a fundamentally different approach, energy-based agents with density-dependent reproduction. This will naturally balance the ecosystem. And so at that point, it rewrites its code and some more little tweaks along the way. Edits, tests, edit, test, until we finally get down to the final result. And so it gives us this last little update on what it did. So let's see what it looks like. So under Hermes, it is saved that as a survival sim. If we double click that and have a look. And there we go. And so we get the various different species all fighting for survival. We get graphs down here, stats. So there you go. So if you had to have sat there and copy pasted all of those revisions out and tested them and given feedback at each stage, it would have taken a lot longer. So that shows the main benefit of using the slash goal in Hermes, because it is virtually just self-contained and it does its own research and coding and editing and bug fixing until it gets a final result that it's happy with. Okay, so let's just clear that so we get a fresh Hermes. Just say you're going out for a few hours and you want Hermes to do some coding for you. You can always give it that single prompt like this, which we did, or you can schedule it and so it will run multiple runs of this prompt. Okay, so if you want a batch of commands to run, add a leading prompt like this. Program me 10 versions of the following. Use a new agent each time. Run them one at a time rather than in batches. Why I say run them one at a time rather than in batches is because by default, if you do not include this, it then launches them 3 at a time. And I found that that reduced the quality of the output since there's less tokens per agent and system to code and debug, etc. And so with that first line, Hermes then runs this same goal prompt here 10 times on its own, hands-free. Say you're going out for the day and you've got a new idea for something, you can say 10 versions, 20 versions, kick it off and off you go. That all runs locally. It's free. You aren't paying for any tokens in the cloud. So just as an example, let's run this. So the same as before, we just paste that in and off it goes. Since that prompt wasn't too specific, it should give us 10 unique results for a species simulation. So we'll see how that runs once it's done. Okay, so those are finished now. Let's have a look at what it coded up. Version 1. Okay, start that. Right, and so it's got a world here for us, plants, species going around, graphs, stats. So speed that up. That one's interesting. Version 2. Okay, a completely different, looks like an undersea ocean type environment. And so this shows how the more general prompt can lead to a wide variety of results. Version 3. Four. This one's interesting. It's even created little animals with antennas. They've got health bars. Version 5. Six. Don't know what this one is doing. Seven. Eight. Nine. And 10. I've also got some from another PC I ran overnight, so let's have a look at those as well. Going a bit fast. These all use the same prompt. This one's going really slow. It is ticking over. Probably needs like a 50 times speed button. Oh yeah, we can see them slowly moving. Actually, let's just do a quick prompt to fix that and make it faster. So in this case, copy the path to the file you want it to look at. Start up Hermes again. And once Hermes is started, you can ask it, so we'll say edit that HTML file, add 2 extra speed buttons, one 20 times and one 50 times. Okay, and so that's made that change, so let's have a look now. Okay, so 20 times is a bit better, you can actually see them moving. Okay, so that shows how you can make a quick patch to the apps if you want something changed. Next example. Okay, this just made a node-based spring something. Deep sea. Okay, so we've got the plankton on top, the jellyfish eating the plankton. Cave ecosystem. Okay, not sure what that's showing there. And version 10. Sky Archipelago. Okay, so all of those 20 examples were made from that one prompt. It ran hands-free. I didn't have to babysit anything, which is really nice if you want to have a whole bunch of prototypes like this. If I wanted a more specific type of species simulation, I could have expanded the prompt. You can make that prompt as complicated or as simple as you like. Okay, now let's look at some other examples I found while I was testing the slash goal. Let's see. Okay. Particle life. Okay, now what this does is it's got different types of particles and some of them attract others and some of them repel others. With these different values of attraction and repulsion, you can get these interesting results. A tropical fish aquarium. And that prompt was basically make me a 3D tank of tropical fish. This one had a few extra prompts because getting the fish to look like fish at all was difficult. It had problems with that, but it works okay. Whiteoar, which is an extended version with 5 species all fighting for dominance. That works well, has a nice graph. 1942, the arcade game. Let's give this one a go. So So that's that one. A smooth particle hydrodynamics simulation. And so for this one, I wanted to see if it could simulate the Rayleigh-Taylor, those small like mushroom shapes that happen if you pour different density fluids together. Like if you think of like pouring cream into coffee, you get those little like mushroom fingering patterns. And so after a little while, you do start to get those patterns in this simulation here. And this was only a few prompts in the end. Okay, a lava lamp. And so you get your particles at the bottom that heat up, flow up to the top, cool down, and come back down. It's not authentic to a real lava lamp, but I thought it was kind of interesting as a quick test. 3DL systems. This can like make trees, etc. And this one, it was the first result. I didn't have to tweak anything. Root finding fractals, or the Newton fractals. You can zoom in, click and drag, various types, colouring. Yep. Another species sim that I tried before. This one's a bit more balanced. And so you've got the plants, herbivores, omnivores, carnivores, and apex predators. And so they go around and feed on what they need to feed on and breed. Nice graph up here. You can speed that up if need be. Okay, a wave tank using smooth particle hydrodynamics. As the tank tilts back and forth, the water inside sloshes around. This one took many prompts and many batches to run. Fluid sims are notoriously difficult to code, and finding those working parameters can be really tough. But after a lot of back and forth, it managed to come up with this result. And another wave tank, this time with 25,000 particles instead of 8,000. This is still single-threaded CPU, so not bad at all. It managed to do a lot of optimizations to get this running. It's 25 frames per second instead of 60, but that's still pretty good. Okay, and version 3. And this time I wanted to see if we could add some floating objects. And after a lot of prompts, this is as far as I could get. They tend to bounce on the surface rather than floating sort of inside like this one should be. And they don't turn well because at first a single particle would hit them and they'd spin around really fast. So I've slowed that down, but it seems a bit too slow now. So those are some more examples of using that /goal. You can get a lot more complicated results. Okay, so that covers the latest tutorial on Hermes and Llama CPP for local, private, and free vibe coding on your own machine. I hope that helps. If you've got a capable GPU, I highly recommend you try it. Thanks for watching.